Okay, number 7. Okay, so on number 7, was it part A or part B that we had trouble with? This is a technique we did cover, but not sure if we remember. Or do we need to just look at both parts? Okay. So we have limit as x approaches 6, the square root of x plus 10 minus 4 over x minus 6. Okay, so this is one, the technique for part A, the technique is multiplying by conjugates. Whenever we see a square root like that in a limit, and this is a technique you want to make sure you know how to do. And we did do it back in probably chapter 1 then. For us, it's not the same as what's in the book because we're not following exactly the same chapters. But what you do is you want to multiply by the conjugate of whatever has the square root in there. Because if we try to do direct substitution, we are going to get an indeterminate form 0 over 0, right? So I plug in 6, I get square root of 16, which is 4. 4 minus 4 is 0. 6 minus 6 is 0. So I have an indeterminate form. So we multiply by the conjugate of the numerator, and that will allow us to have something that cancels. Okay? So this whole multiplying up here, we can use a difference of squares to help us out with that. I am not going to distribute or multiply the denominator. I'm just going to leave that as x minus 6 times the square root of x plus 10 plus 4. But this one, if I do the difference of squares, I'm going to have the square root of x plus 10 squared minus 4 squared. Because I have the difference of squares, I can go ahead and write that out. So that will cancel out my square root, which is what I want. That will give me 16. And so then that gives me the limit as x goes to 6. So this is going to be x plus 10 minus 16. So that ends up with x minus 6, which will cancel with the x minus 6 in the denominator. And I'm left with the limit as x goes to 6 of 1 over square root of x plus 10 plus 4. Now, this is a good technique because you will possibly see problems on the AP test, multiple choice problems, where they're not going to ask, what is the limit of this? Which we could just do L'Hopital's rule. But they're instead going to say, which of the following is equivalent? And they will write out this. And so you're going to have to understand this process to be able to find that this is equivalent. Okay? So this process is one that you would want to make sure you understand. Okay? I know it's one that we didn't really, hit on a lot, but we did cover it. So now I can go ahead and do direct substitution, and I would have 1 over, that'd be the square root of 16, so that'd be 4 plus 4. So 1/8 should be the result for part A and part B, because the L'Hopital's rule should be the same. All right, so part B. So since there are 2 parts on this one, it is a short day, I'll do number 15 later on as a video. Okay, so we'll finish this one and then jump into our lesson. So L'Hopital's rule now, we should get the same result of 1/8. We want to go ahead and start with that. You can call it a limit sandwich or a zero sandwich. But we have the limit of the numerator. So square root of x plus 10 minus 4 equals 0, which equals the limit of the denominator, x minus 6. Since that is true, then our original limit, which is the square root of x plus 10 minus 4 over x minus 6, we can go ahead and take the derivative. Now you need to remember that we need to rewrite that square root as a power of 1/2. So I am not going to simplify the derivative, I'm just going to get the derivative. So if this is x plus 10 to the 1/2 power, my derivative should be, using our power rule and chain rule, 1/2 of x plus 10 minus 1, so that'd be negative 1/2. And we would times it by the derivative of the inside, but the derivative of the inside is just 1. So then I can say minus 0 because that is now gone. And the derivative of the denominator is just 1. So really, this is just the limit as x approaches 6. So I guess I am going to simplify it a little bit. Because this one, I have now a negative power. The 0, that's gone. It's over 1. So all we're really left with is this that I'm circling. And so since the x plus 10 is in the denominator, 2 is in the denominator, I have just 1 over 2. 1/2 power is a square root, so that's square root of x plus 10. Okay? So now I can go ahead and plug in 6. And I would have 1 over 2 times the square root of 16, which is 4. And that gives me 1/8 as well. Okay, so both methods give us 1/8, whether we're using L'Hopital's rule or we are using the, what do they call it? Manipulation methods, I think is what we called it. Manipulation of limits. That would be method in part A. Okay? All right, so we're going to be looking at, you guys asked for 8A. 8 is the limit as, okay, so this one, sine of 6x over 4x. This one requires the use of the squeeze theorem. So part A, the technique is the squeeze theorem. But we never really looked at finding we never really looked at finding the functions to allow us to do the squeeze theorem. Let's just talk about the squeeze theorem real quick. So this is like the limit as x goes to 0 of sine of x over x, which uses the squeeze theorem as well. And so the squeeze theorem here would be that visually what happens is that we have this function, say that is squeezed between two other functions, just as a reminder of what the squeeze theorem looks like. Whereas the function that I have in blue, if we try to do that, is undefined at that place, at x equals 0. Okay? But these other two functions above and below it are defined, and we can say within a specific interval, say within this kind of this picture here, if I was to zoom in, I would say that this middle function is always between the upper function and the lower function. And so as long as the limit of the upper function is equal to the limit of the bottom function, and this middle function is always between it, then we could say that the limit of the middle function is equal to the limit of the upper and the bottom. That is the squeeze theorem. Algebraically, we would write that if, let's say, if, let's call this f of x, this g of x and this middle one we'll say is h of x. If f of x is, actually no, g is on the bottom, right? So I'd have to have g of x is less than h of x is less than f of x for all x in the interval, let's say that's from a to b, then, the other condition, sorry, and the limit as x approaches 0 of our top function f is equal to the limit, let's say is equal to some value, a limit, which is the same as the limit of the bottom function g, then our conclusion is that the limit of x is going to 0 of the middle function h of x is also equal to that value. That's what that squeeze theorem says. Now the problem with doing that with here is we don't know an upper function and a lower function to allow us to squeeze it in between. Now the book does cover kind of, if you want to go back into that section, the book does cover kind of ways of finding those upper and lower functions. We didn't cover that in class, and I'm not expecting you to be able to do that, because more often than not, the problems that will be given with the squeeze theorem, they're going to give us an upper and lower function. They're actually going to give that to us, and they actually won't give us a function for h. They'll just say limit of h of x does not exist or something like that. But they'll say, oh, but it's between g and f for all their values in this interval, and that these two, and then you'd have to show that the limit is the same, like we did in our lessons. So again, this one, don't worry about doing part A. Just understand that it is the squeeze theorem that we are using on that one. Okay. All right, so let's go ahead and look at 15 then. Oh, don't need to do that. I need to do this. 15. All right, so there is 15. Okay, evaluate the limit using L'Hopital's rule if necessary. Okay. Yes. All right, so this one can use L'Hopital's rule because it is an indeterminate form. So let's go ahead and do 15. So limit as x goes to 0 of e to the x minus 1 minus x. Now this one you don't have to go and use some other technique. We can just use L'Hopital's rule. So on my little scratch work on the side, I want to just make sure that I get that indeterminate form. So I have e to the 0 minus 1 minus 0. Well, e to the 0, anything to the 0 power is 1, and that's 1 minus 1 is 0. And then, yep, I have x equals 0. So that will give me a 0 over 0 indeterminate form. So I want to say, okay, since the limit as x goes to 0 of e to the x minus 1 minus x equals 0, which equals the limit as x goes to 0 of x, then we can go ahead and do L'Hopital's rule. So the limit, our original limit, of e to the x minus 1 minus x over x, and I need to take the derivative. So where you might have gotten stuck is, first off, I have these parentheses here, but we can go ahead and distribute the parentheses. So that would be, let me just rewrite it. So x, e to the x minus 1 plus x over x. Take the derivative. E to the x, the derivative of e to the x is just e to the x. Derivative of negative 1 is 0, so minus 0. Derivative of x is 1, and derivative of x is 1. So that means at this point, I believe we should be able to do direct substitution. So e to the 0 plus 1 over 1 should just be 1 plus 1, or 2. So 2 is the limit. We can go back and say our original limit is equal to 2. And that would be how I would find the limit for number 15. All right. And I believe that was all that you guys asked for, so I'll go ahead and stop there.